Thanks for coming out and inviting me over to speak. Today, we're going to be talking about kind of modernizing the project management space and kind of talking about software development and what it's like to be a TPMO, especially for those that are kind of been more in the traditional project manager space. What does a technical project manager do? What is a job role? And just kind of breaking that barrier of, hey, this doesn't need to be something intimidating. It's a new skill set you can pick up and learn. So to introduce myself, my name's Taylor Meadows. I'm a CPA and a prior Big Four auditor. I used to work for PwC for a very long time, and now I've since founded my own company called Code ROI. What we do is we help organizations that develop software, whether or not they're software organizations or not. We automate their tax incentives as well as their compliance requirements and do their what's called capitalized labor. We'll get into that in a moment. And provide engineering insights, which is really helpful for a project manager. So you'll kind of see all these tie-ins. So as I mentioned, we'll just do a quick high-level overview of what is software, how is it built. Many of us use software every single day, but we have no idea how it's actually developed. So we'll keep this very high level. You don't need to be technical to see how this works. And then we'll walk through a real code change so you can see how this looks firsthand. Then we'll jump into how companies can save a lot of money related to that software development and some of the different tax benefits. So first, getting into the SDLC, or the software development lifecycle. Who understands how code is developed, tested, and deployed? Let's write a book on it. We'll do a little bit of an analogy here. To kick us off, I just want to explain kind of two different software development lifecycle flows. You'll see the one on, I think it's the left, is what you call the pre-production flow that you see here in orange. So this is where a developer is developing kind of within their internal environment, where this is where they create their code and they push it to an internal branch. This is not being deployed out. And then you'll see that QA testing and product testing comes after it's being merged to that branch, which if you think about it, makes sense. The QA engineer needs to be able to go test something. Until it's there, they got nothing to test. But it's the flow for the production flow is different, because for the production flow, we want to make sure that we do all our testing before it makes it to the end user. It's a little bit too late if it comes after the fact. So getting into how the code is built. First, commits. Think of commit as like a sentence in a book. It's a very small amount of code that an engineer creates. They will then package up multiple sentences, think like a paragraph, into an envelope in order to send up to their company server. That process of sending that small package of code is what's called a pull request, or for short, a PR. And there are, again, typically many commits or sentences that go into a single pull request. So after the pull request is sent up to the company server, that's where it will then be tested. As we just mentioned, this is where your QA engineer will get in, your product engineer, and basically validate that, hey, is this code working as intended? Is it meeting my product requirements? Just think of it like an editor when you're writing a book. They're validating what you're writing looks good, no grammar mistakes. Then they will do what's called a final review before the code gets deployed out to the production and to your end users. Once you have all your reviews and approvals complete, they'll go ahead and bind it and ship it out the door. And this is where now we have an end product. We have our book. Now, if this was an update to an application on your iPhone, now you as the end user are impacted by that update, whether positively or negatively. All right, so we'll dive into kind of the business process to support the software development team. And for many of you, you should recognize this framework. I'll keep this high level since I feel like a lot of individuals know this framework pretty well, but for those who don't, just to go into an idea of what the Agile framework is around Scrum. The idea is that you have a product manager who is responsible for coming up with the project vision. They're figuring out, hey, what are we going to build? How does it need to look? How does it need to function? And they will break up all their wants and needs into little tiny bite-sized pieces called user stories or tickets. Typically, they'll use a tool, something like Jira, Notion, Linear, and that's where they're going to put in all their different product requirements. Then at the beginning of the 2-week sprint, this is what's called the planning session. This is where they go ahead and pick out what are the tickets we are going to be working on in this sprint. What are we prioritizing for this sprint? And assign them out to the corresponding engineers to work on. Now we get into kind of the actual development of it, which is the implementation period, where the engineers are now working on those tickets. Throughout this process, they are doing a daily scrum. This is typically like a stand-up meeting. Literally in the name, stand up. It's supposed to be short, brief, to the point. This isn't used for problem solving. It's basically just giving a quick high-level update. What'd you work on today? Any blockers? And then moving on to the next person. The idea, it should be about a 15-minute meeting. And then if there's something that needs to go more in depth, that's when meetings come after, but not just hold up the entire team for the process. Then they'll get to a sprint review meeting at the end of the 2-week sprint. This is where they will typically demo what the engineers worked on during that 2-week sprint to the stakeholders to see, hey, what did the engineers build? And is it functioning how I imagined it to function and look? And then after they do the demo to the engineers, the next meeting is what's called the sprint retrospective. This typically you do not have kind of the leaders in the organization. Here, this is more for internal purposes, so that way team members can really feel comfortable sharing how did the sprint go. Like, hey, I really hated working with Bob. He does not know what the heck he's talking about. The idea is for you to be very open and figure out, hey, what's working well, what's not, so we can improve it going forward, and not to hold anyone, to get anyone in trouble. We want people to feel comfortable talking in these meetings. And then at the very end, after we do multiple sprints, when we complete the project, then we'll do the same idea with a project retrospective meeting. You can have, depending on the size of the project, you can have as many as 5 sprints to 20 sprints. It just depends on the size of the project. Any questions on the Agile framework? Perfect. So, kind of circling back to software development, I just want to kind of show you the scale of what does software development look like. So, a typical team composes of 10 engineers, a typical Scrum team. And each one of those engineers will do anywhere from 2 to 5 commits of code per day per team member. And that gets wrapped up into 1 to 2 pull requests, think of that envelope, a day per team member, which equates to roughly 500 lines of code on average per pull request. And with sprints last 2 weeks. So with that being said, you're looking at, on average, roughly about 200,000 lines of code being changed every 2 weeks. And it only takes one small little mistake to cause an outage. Isn't that pretty crazy? So we're looking at 9,600 estimated commits made annually by one Scrum team, which equates to 4.8 million lines of code being changed annually by one team. You see how easy it is for bugs and to get into code and us to have issues. That's why it's so important that we're doing good, solid testing, we're following the framework, we're trying to do our best to prevent those bugs to making it to the end users. So, like I said, it only takes one bad code change to cause a massive outage. And to kind of give you an example of kind of one of those outages real quick is kind of the CrowdStrike outage. The idea is for a TPM it's to manage those engineers, to make sure that they know what they need to be working on and that they're meeting those goals. If there's something blocking them, helping them figure out how to remove those blocks. So this is a PM is going to work very, very closely with their engineers, almost thinking as like the parent, the mother hen, to make sure that everything is cleared so the engineer is able to complete their sprint, complete their work, or if it becomes unreasonable that they're not going to be able to provide that help and support and backing for that team. So, project managers are extremely important within the software development world. Often the TPM will work very closely with the product owner. The product owner will typically set the requirements like, hey, this is something, it's a launch blocker. We really got to make sure that we get these features built out first. And then the TPM will then take those tickets, package them up, figure out within those tickets, which ones are best to assign to which engineers based upon their individual skill set and based upon how much work is going to take to complete those tickets. So some companies will assign kind of a time estimate to the amount of work, or they'll use what's called story points, which is basically amount of effort. And that's where those tickets will then get assigned out to those engineers to then work on. And actually, before we get into this example, since I think it's kind of a good stopping point, I'll go ahead and just walk you through what a code change looks like. So this is that ticketing system that is very common to be used in software development. This is called Jira. There's tons of different flavors, whether you're using Jira, Notion, Linear, Monday, there's a lot of them out there. They essentially all do the same things. They all function very, very similar to each other. It's kind of pick your flavor. But this is where you will see kind of a backlog of tickets that need to be assigned to engineers. So if we just pick an example ticket here, we'll just, again, keeping this simple. I myself am not an engineer. Again, background CPA, PMP. So we're going to keep this super high level. So in this ticket, we're just going to be adding the text, hello world. So if we go into what's called a code repository, this is what's called GitHub. GitHub is the largest code repository in the world. They own about 92% of the market share. So very good odds that your company is probably on GitHub. And what a code repository is, it's nothing super fancy. It's basically just where code is stored. So this is where engineers will typically write the code on their laptop. And when they send it up to that company server, that is GitHub. This is where all that code is being stored, processed, and being ran from. And GitHub just basically makes sure that you're kind of following the traditional software development lifecycle flow. So we're going to go into GitHub and say we're an engineer, and we're going to go ahead and make that code change. We'll go in here and click edit, and we will go ahead and add the text, hello world. So again, we walk through the process of what it's supposed to look like when you're going through the software development lifecycle. But if you don't have any of the proper guardrails set up, you can just go ahead and you click commit changes, add a little commit message of add it, text hello world, and commit changes. That is literally how code can be deployed if there are no restrictions and guardrails set up. Clearly, that is not good. You don't want a developer just writing code and just poop straight out to the end user. Good luck. Hope there's no issues. So that's where we want to make sure that they are following the proper chain of command. They're doing the proper reviews, proper testing. So I'm going to go ahead and walk you through another code change, but this time we're going to walk you through an example of what it looks like when there is enforced segregation of responsibilities, enforced approvals to ensure that everything is actually being performed before that code makes it out into production. So we're going to do the exact same thing. This is on a different branch that is being managed by our CodeRI platform. So you get an idea of how code should be developed. And honestly, most of your teams are doing this today. The only thing we're doing is putting a true system limitation to ensure that happens, to ensure you can't just cut the corner. So this isn't actually changing any process flow. This is just ensuring the process flow is occurring. So now we'll go ahead and do commit changes. And again, we add a little commit message. And this is where we can also, enter our time as an engineer. Hey, how long do you spend working on this? So let's say we spent an hour and 25 minutes working on this code change. We'll do proposed changes. And then now, remember we were talking about you take that commit and you put it into a pull request. So this is where now that commit is being packaged into a pull request and we're sending it up to that company server. We'll go ahead and log, hey, is this a feature bug task? So we'll say this, if we look back at the Jira ticket, we can see right here, this is a feature. So go back into the pull request, mark it as a feature, and is this something that is ready or not for QA testing? It's just more or less a flag so the QA engineer knows what they can go in and move forward on testing. So now we'll go ahead and create that pull request. Oh, actually, before we do, let's go ahead and we will copy a link to that Jira ticket we're working on, and we can paste it in here, and we can actually tie this all together. So that way we can tie the pull request and the ticket together all into one. So we'll go ahead and create that pull request. Okay, now the pull request is created. We again want to make sure that we're having that QA testing happening, the product testing happening, and what's called a PR review or a pull request review. Think of this as just a traditional code review. Typically, this is a lead engineer who's going about and reviewing another engineer's code. So I'll jump over to a second profile, and right now I'm just using our system in order to make it quick to jump between tickets, but typically you can do all this directly within GitHub. You don't have to go through any of this. So the idea is that from a project management perspective, you need to keep track of what are your engineers working on. So like within our platform, here you can see a list of every single code. Each one of these rows relates to a pull request. So effectively every single code change that your engineer is making, you can see where is it at, what's been completed, what hasn't been. And it's not just you asking, hey Bob, have you finished that? You can go look to see, is it actually done? I don't have to go ask Bob, where is he at in this code change? I know exactly where this code change is at any point in time. So this removes that, hey, I gotta go knock on all these doors. I can just go figure it out for myself in all of 3 seconds. And more importantly, and we'll get into this in a moment, well, actually this is kind of a good opportunity where we kind of have this, this insights module. And this provides a lot of the financial insights around the engineering org. So you can see like how much has been spent on your software development thus far, and what's your cap labor percentage. So how much of your software development can be capitalized? Most companies want to target roughly about 70%. That means that 70% of the effort is going to new feature development, not just keeping the lights on. So this makes it very easy to see how is your org tracking towards that. How much are you spending across each of your projects in real time? We have a variety of different charts and graphs here. I won't go super in depth. And then what I find interesting, if we dive into a specific project, now we can see these same numbers for one particular project. So we're looking at Project Alpha, and we can look to see how is that project compared to our other projects that our other teams are running. So now we can start to identify which ones are performing well or not. And we're doing this for both projects, teams, and individuals. So it finally gives you hard data to substantiate how a team is performing rather than just a gut feeling. And we're gonna have over 150 metrics that you can look at in real time to see how your engineering teams are being performed. We're specifically focused on Project Alpha, but this view here is where I'm comparing Project Alpha to Project Apollo, to Project Beta, to Project Delta. So I can see how these projects are performing against one another. So like in this example here, if you look at Project Beta, I see a lot of red. Well, that brings up the question, well, why is this software development process taking so much longer than it used to? Is this something where this project is winding down, I don't have as many engineers on it, and that's why they're not moving as fast? This doesn't answer the question. It's more just raising the flag that, hey, why am I seeing a downturn? And to kind of go in and investigate. That's why you have the project manager. This is just providing and enabling the project manager to do their job. We have a lot of different reports in here where you can go in here and look at how those teams are performing, not just from an engineering perspective, but also from a financial perspective. So for myself, being a CPA, like I don't fully understand what's going on in the engineering org, which I really like this because I don't have to understand what's going on. I can just see how teams are performing. But what I really like is I get access to all my financial data, so I can go get all those tax incentives and get all that money, which is pretty crazy because through these different tax incentives, you can get up to 50% of my software development spend back each year. That's a lot of money. There's organizations that spend millions and millions, like hundreds of millions of dollars on software development. And you're talking about getting up to almost 50% of that software development spend back at the end of the year. That's a lot more money I can push into engineering. So we're tracking how basically of that, let's say you spend 100 million on engineering, how much of that is going to be eligible for those incentives and how much you're able to get back at the end of the year. This is what kind of ran into the problem of why we created this platform. Is I was part of the team when I was at PwC, part of the team would be deployed when an incident like CrowdStrike happened. So I'd go out there, explain to them how to develop software in a compliant manner to meet the regulatory requirements, improve their operational efficiency, and then help them get millions back related to these tax incentives for their software development. The problem is the client is looking at like, okay, so am I going to get my $100 million this year? And I'm like, well, I need the data. If you can't provide me as your CPA the data in order to substantiate your claims, my hands are tied. I can't do anything about it. So now I'm sitting across them that like, hey, you're not going to get your 100 million. I will settle with you at 5% of what you're eligible for. That's what I feel comfortable signing off on. And you can imagine how pissed the client gets when you tell them that they're going to get 5 million when they thought they were going to get 100 million. So that was a frustration that I had. And I was tasked to work with a company called SHI, CDW, they're very large software resellers, to see if they had a software product that we could attempt to resell to our clients. They didn't have anything for us to do, and I was quite frankly just griping and complaining, and now my CTO, she decided to, enough's enough, and she just decided to actually then become a fixer and solve the problem and took the idea and turned it into an actual functioning product. So that's the really cool thing about this is that it only takes roughly about 15 minutes to set all this up. It's basically the complexity is installing. You know how you go to the app store, you install an app on your phone? That's pretty much the complexity we're talking about here. So yeah, when we do onboarding, we typically, it's everything set up within the first 15 minutes and the rest is answering questions, like letting people just, explore the platform. But we set up a lot of automation in the background to make this a very smooth process because I've done a lot of like SAP, Oracle implementations. They can be like a year-long implementation. Great applications, very difficult to actually get implemented. So that's what we're avoiding here, making it extremely passive. We do not rely on the ticketing system because a ticketing system is effectively a notepad. I can write anything I want. I can say I did anything in there. That doesn't mean it happened. So we pull all our data directly from the code repository. So unless you actually did it, it does not go into our system. So our engine is based upon the actual source documentation, which is exactly what the IRS is looking for. So they're pushing back that if you are pointing to your ticketing system in order to attempt to substantiate these claims, like no, that data doesn't count. You need to be able to point to the code repository, to the source documentation in order to get these incentives. Let's go ahead and we'll go in kind of resuming that process. So now we need to do that code review. So we'll go ahead and we'll go into file changes and submit our review. So this is where typically the lead engineer is going in, performing the review of the code. And we'll just keep this simple, say it looks good to me. And then again, same idea. This is where the engineer can enter their time, how long they spend on this code review and submit review. You'll see here that now the first status check gets cleared and now the code review is complete and now we're pending our QA review. So this is now because in this environment we have enforced separation of responsibilities. This is one of the requirements for a lot of security frameworks, whether it be NIST, SOX, SOC, where you want to make sure the person who's developing the code isn't the person who is reviewing the code and deploying the code. Makes sense, right? So we'll go ahead and jump over to a third account and we'll go ahead and approve QA. And then last but not least, we'll go ahead and do a product review. And just going through this quickly, that way make sure, save plenty of time. So do approve product. And again, can you enter your time here. So if we jump back into the pull request, you'll see that all our status checks have been cleared. So we have our code review, our QA review, and our product review, making sure that that has happened. There is no way for an engineer to bypass these status checks to ensure that these approvals are occurring and not one person is going about and clicking approve on their own code. That's what happened with the CrowdStrike outage, and I'll walk through that example in a moment. So we'll go ahead and do what's called a squash and merge. effectively, this is just where they're taking, where it could be multiple lines of code, just kind of merging it all into one and then sending it up to the server and merging it now into the production database, impacting our end users. So that is what a normal code change process or software development lifecycle process will look like for an engineer. So as I was mentioning about the CrowdStrike outage, if you don't know who CrowdStrike is, they are a very large software security company, and they're actually one of the leaders in the space because they're one of the few companies that look and is able to prevent zero-day attacks. And what a zero-day attack is, it just means that we've never seen this type of attack before. This isn't something that's ever been documented before where we already know, oh, this is the type of attack, this is how we solve it. They were able to detect an attack for the very first time and actually prevent the breach before the breach happens. So, which is really, really cool. They're utilized by over 21,000 organizations and used by several of the Fortune 500 companies. So what happened with the CrowdStrike outage? I'm sure many of y'all remember a lot of the airlines weren't traveling that day because this CrowdStrike tends to be the backbone of a lot of companies. So a lot of companies' computers just literally wouldn't turn on. And so this happened on July 19th. And what happened is when you're developing software, there's effectively two layers. You have the kernel, and then you have the user level. Think of the kernel layer as almost like the cement foundation of your home. Everything's built upon it. You have to run through the kernel before you can get into the user layer. And this code change that CrowdStrike made was directly into that kernel layer, into that cement foundation. Well, what was happening is they had it hard-coded to look for 21 inputs, but there was only 20. So during the boot up process, when you're turning your computer on, it goes to look for that 21st input. Can't find it. It doesn't know what to do. So it blue screens and crashes. So you can't even turn your computer on. You can't get an update to fix it. It's effectively, you have a very nice, expensive brick in front of you. And what that meant is that in order to actually fix this, they couldn't just send an update to all these computers to then patch it. You had to get actual physical access to every single computer, every single server, connect a USB in order to basically boot into what's called safe mode, where it's basically, it has a lot of the services are all turned off. Actually add in, delete the patch that caused this issue from CrowdStrike. That would allow you to reboot the computer and actually get the new update from CrowdStrike so your computer could function. This is what caused companies to go offline for days as they're having to send humans to all these computers to apply this update. So pretty crazy how a single engineer, this is one engineer who decided to push a code change Friday afternoon. It was a senior engineer, and the idea is, what's the worst thing that can happen? If something goes wrong, I'll fix it on Monday when I come back in the office. Well, now we know what's the worst that can happen. They didn't do any QA testing, any product testing. There was no reviews or approvals. The engineer just pushed it directly to production and caused this massive outage. So I think they ended up with a longer break than expected. So looking into some of the insights and outcomes of this, it shows just how reliant we are on technology and how one little code change can have such a massive impact. And to think about it, it was impacting not just CrowdStrike, it's impacting all of their clients. And that's where it's called like a supply chain, where one component of that supply chain fails, it causes everything else to collapse. And that just shows the importance of the impact of vendor tooling and policies. While it's their policy for an engineer not to develop and push to production, is very different than having a control in place to ensure that engineer cannot develop and push to production. And that's the thing, this is what engineers already do today. It just ensures that they can't get lazy. Like we as humans, like sometimes we cut corners. We want to move a little bit faster, but we got to make sure that we're following the proper chain. The idea is that if you know that you're approving something and you're taking responsibility for it, there's a higher likelihood that you're going to go ahead and make sure that you did it right. It's kind of like the idea is Let's say you're at a restaurant and you want to leave your laptop and you ask some random person you don't know, hey, I'm going to run to the restroom, do you mind watching my laptop? There's good odds that random person is going to actually make sure that no one just walks off with their laptop. It's just the idea of placing that responsibility. So exactly what happened with CrowdStrike, that's what I spent most of my career at least attempting to prevent these outages to ensure that engineers are going through this process. Well, we figured out by basically forcing them to go through this process, we're able to capture all the necessary data in order to go in order to then automate all these different tax incentives. And that's where, if we jump into that ticket that we were just working on a moment ago, you'll see where we're capturing the chain. It's effectively a log of who did what and when did they perform the actions and the time. So how long did the engineer spend actually developing that code? How long did they spend doing the code review, the QA testing? And it's this time data that we're bouncing up against the wage information to then automate their tax incentives. So first I want to get into the composition of how dollars are spent in the engineering org. So the vast majority of money is going to the actual human labor, is to paying my engineers, with only a small set, roughly about 5% going to my tooling, and then 3% going to my supplies, materials, effectively the hardware those engineers are utilizing. Which is really cool because what is eligible for these tax incentives is the biggest bucket. The 92% is what's eligible for these tax incentives. And those are the R&D tax credits, the R&D tax amortization, which is classified as 174. And then the last one is what we were just talking about a moment ago, is software capitalization, where you can capitalize this work on your financial statements, which increases a company's EBITDA and company valuation. So we'll go ahead and go through a quick high-level overview of what each of these three are. So for the R&D tax credits, this is a one-time claim where you're able to get the benefit related to that software development spend in order to directly decrease your tax liability. So this is a top-line reduction of your taxes that you're paying at the end of the year. And you can carry this forward for 20 years. So even if, let's say, I'm a pre-revenue organization or I'm not profitable yet, this goes on my books as an asset that I can carry forward for 20 years, or if some other company decides to buy me out, now they get access to this asset. So that really increases the value of the company. And the nice benefit is you can double dip. You can get these R&D tax credits at both the federal level and the state level. And how you determine what is eligible or not for these R&D tax credits is, first we have to look at the underlying project. Is the project itself eligible for the R&D tax credits? Is this something that's innovative, is new? The nice thing is for software development, almost all projects are going to be eligible. That's just kind of part of the process, because we all think we know what we want to build. We all think we know how it's supposed to work. But we always end up iterating, we always end up making mistakes, changing how it's going to function, which is great because that's what makes it eligible. The second part is, after we determine that the project is eligible for the R&D tax credits, now we have to look within the project, what actually within that project is eligible for the R&D tax credits. And that's where our software kind of comes into play, where we're analyzing all of those actions to assess what actions within that project are actually eligible for these incentives. You can't just lump and say, oh, this whole project is eligible for R&D tax credits, or we'll just go with 70% of the project is. If you attempt to do those claims, that's where the IRS is going to audit you. You will not only have that money taken away from you, and you'll also get a fat penalty on top of it. So it can be very damaging if you do not have the data to substantiate it. And that's why often your CPA will stop you and say, no, we're not going to sign off on this, so they won't allow you to make that failure. So looking at the project eligibility, there is a 4-part test. Basically, is it looking to improve something? Is it a hard science? Is there technical uncertainty? And trial and error. Guess what? That's software development. So that's the nice thing, is that a lot of software development is going to be eligible for R&D tax credits. And this doesn't have to be something like a lab coat type work. This could be something like one of our clients, they own 500 pawn shops in the US. You don't think of a pawn shop as someone that is either building software or doing something innovative, but they're building their own auction house, their own inventory management system. So they're innovating by improving their operations. That is work that is eligible for these incentives so they can get that money back at the end of the year. So looking at the steps of development, we can kind of see what within a project is actually eligible for these R&D tax credits. So what you're seeing here in green, these are the steps. So the code development, the code review, the QA review, and the product review are all eligible for the R&D tax credits. And then a percentage of contractors, so in the US, it's 65% of contractors are eligible for these R&D tax credits. That is what is actually eligible. The actual creation of the ticket, the planning, the research going into the development of the code, or the post-production verification testing after the fact, that is not eligible for the incentive, which is kind of funny because think about the name, R&D tax credits, research and development tax credits. Interesting how research isn't actually eligible for the tax credit. Only the development is. So that's kind of a weird, tricky nuance. Just thought I'd point that out. I always thought that was funny. Now, within that, there are two different approaches to calculating what is eligible for their R&D tax credits. You have the traditional approach and then the ASC, or alternative simplified credit. Most companies do not use traditional because you had to be around back in 1984 to 1988, and you have to have all the necessary data since those years in order to even do the traditional approach. So think how many companies can actually pull that off. Very, very, very small amount of companies can. So that's where pretty much everyone uses the alternative simplified approach, which is 14% times the current year QREs, or qualified research expenses. That's what our software spits out. Hey, this is your QRE number, so you're able to get that. And then you're doing that times the average of the prior 3 years. Next is the R&D tax amortization. This is section 174 within the tax code. This provides a slightly smaller tax savings because what this is, and before the R&D tax credits was a direct reduction to your tax liability. This is a reduction of your taxable income. So while the R&D tax credit was top line, this is essentially further down where we're reducing the taxable income itself. And previously, for domestic work, you would be forced to amortize it over 5 years, and international work over 15. The idea is to encourage domestic development. Well, they just recently changed this and increased it, where now for domestic work, you can actually amortize this work over the first year, 1 year. So you get the full benefit, a full tax benefit all in year one. You don't have to do it over 5 years anymore, while the international is still 15. As you can imagine, this is to encourage a lot of the R&D work to happen onshore, to happen in the US, rather than sending the engineering work overseas. And again, you can get this benefit as well at both the federal level and the state level. So it's really nice you start getting to double dip. And the R&D amortization works extremely similar to how the R&D tax credits work, where you have to look at the underlying project. Is the project eligible or not for these incentives? And then looking at the actual actions within that project to see what actions are eligible. And that's what you bounce up against the user wages in order to get these tax deductions. Look at project eligibility. You notice something similar? It's the same process. As you see, there's a lot of overlap between the tax amortization and the R&D tax credits. So you're able to effectively get 4 different avenues to reduce your taxes at the end of the year. And that's how you are able to get up to that roughly almost 50% of your software development spend back at the end of the year. For R&D tax amortization, it's a little bit different on how what is eligible. So the ticket creation is not going to be eligible for the tax amortization. The PPV review, which is post-production verification testing, this is essentially the testing after the code has been deployed to production. So this is after it's been deployed, is it working as intended? If you're working on a project that is pre-launch, what that means is that you are developing a project that has not been launched to end users. This is something that we're working on internally within the company. We have not deployed it out to end users. That work is eligible for the tax amortization. However, the moment we start getting our true end users on the platform and we really start hitting scale, now that work is no longer going to be eligible. The code review, the development, the QA review, product review, that's going to be all eligible for the tax amortization. And the nice benefit is you get the full benefit, whether they're an employee, whether they're a contractor, whether it's domestic or international. So a lot of value here. And this is kind of a little breakout of how this process works. Effectively, it's actually very simple to read this, is if the work is being performed internationally, you get the benefit spread out in small little bite-sized pieces over 15 years. Or if the work's done domestically, you get the entire tax benefit all in year one, immediately directly reducing your taxable income. Then when we get into cap labor, or what's called capitalized software development. This is the idea of this, it's almost like an accounting trick, which allows an organization to move their software development expense off their P&L or off their profit and loss statement and over to their balance sheet as a capitalized asset. What this does is this increases the company's EBITDA by an average of 15% and their company valuation. So this is something that executives are often really pushing, is how can we get that EBITDA number up? This is a really, really nice tactic to increase that EBITDA. And to set clarity, this is not related to taxes. This here is related to your financial reporting. So whether you'd be reporting to your investors or reporting to the street, this is for your financial statements where software capitalization comes into play. This is not going to the IRS. So how software capitalization works, we would look again at the R&D eligibility percent for each user, and it's that percentage that we're essentially bouncing up against the user's wages information in order to get what is considered capitalized software development. Here you can kind of see the breakout of what qualifies and what doesn't for software capitalization. So again, you would think a lot of the research would qualify, but it doesn't. The ticket creation does not qualify, but the hands-on development work, the testing of that work, that's what qualifies for the software capitalization. And you get this full benefit, whether it's domestic or international or employees or contractors, you get the full benefit of this. So it's a really nice trick to increase the valuation of your company. So what the CPA is going to see is we go over to our tax savings dashboard. These are the numbers that the CPA needs in order to literally copy and paste directly onto the tax return. So here's the R&D tax credits at the federal level. Here's those tax deduction savings at the federal level. Here is your R&D tax credits at the state level. Here's your tax deductions at the state level. It is literally a copy and paste function now for the CPA with data to substantiate and back it up so that way your CPA can feel comfortable signing off. Because that's the thing, is a lot of this, there was so much work and labor that went into it. It was typically only the biggest companies that would even have a chance at getting these incentives. Now a small startup can get some access to some easy non-dilutive funding to help them actually build their company. So one, it helps when you're going through an audit from a compliance perspective. Now you can point to true system controls to show that yes, my engineers have enforced separation of responsibilities. Yes, there is testing that's happening before this code is making it out of production. So that makes it really nice from a compliance perspective. Also, from getting in from a financial side of the house, the different tax incentives, now project managers are the ones that are essentially held accountable for collecting of this information and extracting it from the engineers. Now it makes it a whole lot easier for the project manager to get the information they need to hand off to their finance teams and to their CPAs. And then lastly is those engineering insights where you have that hard, granular data to be able to see how your teams or individuals are performing. The idea is this is not solving everything. It's a tool to be leveraged by the project manager. What's really cool about AI is that the R&D tax credits and all these tax incentives is specifically related to the dollars that you're spending towards human engineering. So just because the human engineer can get more work done because of AI, I'm still getting the same incentives for that engineer. But you do also get a bonus is because the dollars I'm spending on AI, that's enabling that engineer to do that extra work, that's also eligible for these incentives. So now I'm able to get even more money back. If it was purely an AI doing the work, then no, you wouldn't be able to get these incentives. But no large company is doing that today. We leverage AI in our software development. It's a tool. It's kind of like Excel. Does it enable us accountants to get more work done? Yeah, it does. Is it going to replace us? No. It's a tool. It allows them to do a lot more work in a short amount of time, but it's a tool. Well, thank you, everyone. Appreciate it. Y'all have a great day. Thank you for having me out.